Hello students, welcome to today's video again. We're just continuing the exponential equations. So in the last video we finished all the creative sections A. Now we are now in creative sections B of Vedanta Excel Mathematics class 10, page number 203 and 204. You can see there. Okay, the questions goes like this, and this type of questions will probably be asked in the examinations in SCE, higher probability. Okay, don't just miss out this type of questions. Now, okay, try to see this 11a. So in the 11a, given exponential equation is 4 into 3 times power 4 times 3 power of x plus 1 minus 9 power x is equal to 27. So these types of question we have already done in the in the creative section A also. So you have to solve this question, okay, and after solving this question in solve the given equation, you have to solve this equation and you have to find the value of x here, and after getting the value of x, prove that the values of x obtained by solving the given equation also satisfy the given equation here. Okay, so whatever the value of x will be whatever value of x will we get from by solving this above equations. So we have to prove that whatever value is that we get by solving this equation, that also satisfy, when you put the value of x here, it also satisfy this equation. You have to prove it, and this one is very easy. Okay, let's get into it now. 11a. So let's go into the given equation. We have given equation we have 4 into 3 times x plus 1 minus 9 power x is equals to 27. Now just like we did in the previous video, you just disintegrate this, okay, and 3 power 1, and 9 can be converted in express in power of 3 power 2, and x is already there. Okay, now you suppose or let 3 power x be a, then after you just replace 3 power x by a variable. 4 times 3, you can write directly 4 times 3, that is 12, and 3x you can substitute that by a minus, and here it will becomes a square. Let's move 27 to the left hand side, it will become minus 27 equals to 0. Okay, express, try to put this in general form. Plus 12a minus 27 equals to 0. Okay, now take the minus common here. A square minus 12a plus 27 is equals to 0. Now minus will disseminate with 0, and the remaining will be a square minus 12a plus 27 equals to 0. Now we just factorize this. Okay, 9 times 3, 27, 9 plus 3, 12 plus 27. So factorizing is the most important, okay? So you have to know how to factorize this. If you don't know factorizing, then try to seek help from your junior brothers, sisters, or whatever. Okay, minus 3 a minus 3 9 27 equals to 0. Now you just write here a minus 9, another a minus 3 equals to 0. Now you can do either a minus 9 equals to 0 or a minus 3 equals to 0. Now further simplification, a equals to 9, replace the a by 3 power x, and 9 can be expressed in power of 3 power square. Now equate powers, you will get x equals to 2. Similarly here also, a is equals to 3. Now replace value of a by 3 power x. 3 power nothing means there will always be 1. Equate powers, you will get x equals to 1. So there are two values for x. Therefore, you will get the two values of x. One is 1 and another is 2. Now, so you got the two values for x. One is 1 and another is 2. Now try to put the value of when x equals to 1, you try to substitute the value of x by 1 and try to satisfy this equation, and then also try to substitute the value of x by 2 and satisfy these equations. And for number I, when, so we got the value of x 1 and 2. Let's first take when x equals to 1. So given equation is 2 power x plus 2 power 3 minus x is equals to 6. Now just substitute the value of x by 1. 2 power 1 plus 2 power 3 minus 1 is equals to 6. 2 power 1 means 2. 2 power 3 minus 1, that is 2. 6. Now 2 plus 4, which is 6, is equals to 6. Yes, satisfied. Okay, satisfied. Okay. Now again, when, so there is not much space there, so I'm gonna write here again. Okay, again, when x equals to 2. So when x equals to 2, then just say try to substitute the value of x by 2. 2x plus 2 power 3 minus x is equals to 6. You just substitute the value of x by 2. 2 power 2 plus 2 power 3 minus 2. The value remains the same. It also satisfies the same. Okay, so 3 minus 2, that is 1. You don't need to write this. Or 6 equals to 6, satisfy. Yes. Okay, for both values of x equals to 1 and x equals to 2, this equation is satisfied. Then it is proved. You can write here, proved. Very easy. Okay, so until you have whatever you have read, all will be used here. Okay, so if you find confused in this type of questions, let's do another. 11a I have done. Let's move on to 11b also. Okay, so while doing 11b, you will be more clear. At this one, nothing. Okay, let's move on to the 11b. You will be more clear about this. So only the equation is given. Okay, only this part, the question is same, only the simplification part is different. So given exponential equations is, so let's in I is the same question. Solve the given equation. You have to solve this given equation. 49 power x plus 7 is equals to 8 7 power x. Now you move this to the 49 power x plus 7 minus 8 times 7 power x, okay, equals to 0. Now 49 can be expressed in power of 7 squared, x is already there, and minus 8.8.7x equals to 0. Let a equals to 7 power x. Then you just substitute 7 power x by a. So this will become a squared plus 7 minus 8a is equals to 0, or a squared minus 8a plus 7. Try to arrange it in standard form. Okay, now just factorize this. A squared minus 7 plus 1, a plus 7 equals to 0. A squared minus 7a minus a plus 7 equals to 0, or you just take a common a minus 7, nothing means minus 1 common, a minus 7 equals to 0, or a minus 7 a minus 1 equals to 0. Now you can do either a minus 7 equals to 0, or a minus 1 equals to 0, or you can write it a equals to 7. Now substitute the value of a by 7 power x. So this will be 7 power 1, equating powers. You will get x equals to 1. So similarly, a is equals to 1, or 7 power x equals to, now 7 power 0 will be 1. Equating powers, you get x equals to 0. So here are two values for 0. Therefore x equals to 1 and another is 0. Now try to satisfy this value in the next equation here. Now for double I here, given equation is 9 power x plus 3 is equals to 4 times 3 power x. Then when x equals to 1, try substitute the value of x by 1 first. Okay, now 9x plus 3 is equals to 4 times 3 power x. Just substitute the value of x by 1. 9 power 1, 3 equals to 4 times 3 power 1, which is 9 plus 3, 12. 4 3s are 12. Satisfied. And again, for another values of x, when you have to satisfy the both values. When x equals to 0, then 9 power x plus 3 is equals to 4 times 3 power x. Now 9 power x, 9 power 0 plus 3 is equals to 4 times 3 power 0. So 9 power 0 means 1, and 4 into 3 power 0 means 1. So 3 plus 1, 4, and 4 into 1, 4, which also satisfied. So you have to prove this, which is proved. Okay, you got it. It's very easy, nothing so much difficult here. Okay, I think this one is the most I think even easier than the other. Okay, now without further delay, let's move on to the number 12, question number 12. So I'm going to rub this. So if you want to copy this, then just take a screenshot. Okay, now let's move on to the number 12a. So in 12a, the area of the window is given there. Now from this question you have to make the equations, exponential equations. Yes, definitely. So first you have to understand the what is given in the equations, then after, by using the conditions here and given variables, you have to make the equations. Okay, now the area, let's read out the questions for you. 12a, the area of the window is 4 power x square meter. That will be the area of window. So you're given it area of window. So area of window is given 4 power x meter square. Okay, and the curtain of size 5 meter by 2 meter is used in the window. So to cover that window, we have a curtain, curtain, curtain size. The curtain used in that window, the curtain size is 5 meter by 2x meter square. 5 meter by 2x meter, which is 5 meter times 2x meter. So this is the curtain size. So the condition is given that the condition is given that the curtain is 4 meter square more than the area of window. So the curtain size is 4 meter square more. Okay, so if you area of window, okay, the curtain size is 4 meter square more than the area of window. So this is the area of window and this is the curtain size. This the curtain size which will be used to cover the area of window is 4 meter more. So to make this equal, you have to add here 4 meter square. This curtain size is 4 meter square more than the area of windows. Now you have to uh, use the given condition and make equation like this. Now replace the value. Okay, so here curtain size is, we have 5 meter by 2 times x meter, and area of window we have 4 power x meter square plus 4 meter square. Now this is the equation that we need to solve. But until you solve this equation, you just neglect this m. Okay, just this variable. You just write only 5 into 2 times x, 2 power x, 4 power x plus 4. Yes, you only write this. Then after you just simplify. Now let's move all to the left hand side. 5 plus 2 power x minus 4 power x minus 4 equals to 0. Or 5 plus 2 power x, this can be expressed in terms of 2 power 2x minus 4 equals to 0. Let, there is some mistake I have done here. So there is multiplication, I have written here plus sign by mistakenly, so I'm gonna correct this. Okay, let 2 power x be supposed by some variables a. Then now substitute the value of 2 power x by a, then it becomes the equation becomes 5a minus a square minus 4 equals to 0. Or just write it in the general form, 5a minus 4 equals to 0. Take minus common, you will get a square minus 5a plus 4 equals to 0. Or a square minus 5a plus 4 equals to 0, you can write. Now factorize this. 4 plus 1, a plus 4 equals to 0. A square minus 4a minus a plus 4 equals to 0. You just write a common here, a minus 4 minus 1, a minus 4 equals to 0. So a minus 4, another a minus 1 equals to 0. So either a minus 4 equals to 0 or a equals to 4. Now replace back the value of a by 2 power x. 4 can be expressed in 2 power 2. Equate powers. You will get x equals to 2. So similarly, just like that, a minus 1 equals to 0 or a equals to 1, or 2 power x equals to, so when 2 power 0 is equals to 1, equate powers, you will get x equals to 0. So there will be two values for x, that is, one is x equals to 2 and another is 0. Now after getting the values for x, now you have to find the then. So there are some questions that I just forget to. So there are some questions. This is not only the questions, okay? Only the partial part I have finished, okay? So I'm going to write the the remaining questions of 12A. Okay, I forgot to write the remaining questions of this 12A. So these are the the questions of this, the part of this questions, okay, this one. So in the first number I, make an exponential equations, that we have done already here, Okay, this one is the exponential equations. So this one is the exponential equations we have done. So look here, this one is the exponential equation. Okay, so solve the equation for x. So we got here two values for x. This is for from here it will start the number 2. Okay, solve the equation for x. So from here we start to find the values for x, solving this equation. So this one is for I, and this from here to here you will get this double I equations, and find the possible area of window. Now area of window, possible area for window. Yes, so there are two values for x. One is when x equals to 2. So what do we have, area of window? Then area of window will be 4 power x. So replace the value of x by 2. This will be 16 meter square. So after this is one possible area of window, 16 meter square. Another possible area, you have to put the value of x by 0. Replace the value, substitute the value of x by 0. You will get just another answers for that. So I'm going to rub this part. Okay, from here to here you will be needing that no more. Okay, so by putting the value of x equals to 2, you will get the area of window 16 m square, 16 meter square. But when x equals to 0, then area of window, will be, just substitute the value of x by 0, 4 power 0. So 4 power 0 means 1 meter square. So the possible areas of window will be either 16 meter square or 1 meter square. Okay, these are two exceptional areas for window. If you put the value of x, substitute the value of x by 2, you will get 16 meter square, and if you substitute the value of x by 0, you will get 1 meter square. So after this, let's move on to the next. So in number IV, possible area of curtain. Now possible area for curtain. So in that case also you have to put both the value of x. First substitute the value of x by 2, then you will get another value, and substitute the value of x by 0, you will get another value. Okay, so when x equals to 2, then area of curtain, area of curtain and size of the curtain means same. Yes, curtain size we have, area of curtain will be 5 meter into 2 power x meter, which is 5 meter into 2 power x, we have 2. So which will be 5 times 4. 2 power square means 4. 5 was 20 meter square. Okay, if you substitute the value of x by 2, you will get 20 meter square as the area of curtain. So if you put the value of x by Now if you put the value of x when x equals to 0, then area of curtain will be 5 times 5 meter times 2 power x meter, which will be 5 times meter into 2 power x. We have 0, so 2 power 0 means 1 meter, which is 5 meter square. So therefore area of curtain will be either 20 meters squared or 5 meters squared. A little bit congested there. I hope you understand this. Okay, so it doesn't look like a square here, so I'm gonna make it like a square. Okay, so while you're copying that, you won't get any problem. So this is how it is done. Okay, so now this is number 12A. So if you find this problems a little bit difficult, let's move on to the number 12B. 12B, I think if I do number 12B, it will be more clear. Okay, let's move on to the number 12B. Okay, so I'm going to rub this. Now let's move on to the number 12B. 12B is same like this. Okay, no need to worry about this. Okay, now I'm gonna rub this. Now let's say in 12B. Okay, in 12B, Mr. Upreti brought a plot of 5 ana land. Okay, he brought a plot of 5 ana land. That is his total land area, 5 ana, in a municipality. Now he has built a house covering the space of 4 power 2 minus x. He has built a house covering the space of, so within those 5 ana, this area, this part of area 4 power 2 minus x, that is for the area for the house. Okay, so that much space is occupied by the house, and kitchen garden covers the remaining 4 power x minus 1. Okay, ana of his plot. So the house covers this much part, and the remaining after building the house, whatever remaining, the remnants of the land, that is 4 power x minus 1, that is covered by the kitchen garden. So when you add those, this will equivalent to the total land he bought, that is 5 ana. Okay, let's go into that. And after that, after that, first you have to make the exponential equations. It will be easy for you, and solve the equation for x. You'll get just like we did in the 12A. We'll try to solve we'll try to get the values for x and find the area of kitchen. So whatever value of x we'll get, so try to embed, try to put all the values for x, that whatever we have get in the to get the possible area for the house and possible area for the garden. Here also I and IV, find the area of kitchen garden. Okay, so if there will be, so this is the quadratic equation, there will definitely be the value of 2's values for x, so you'll get the 2 possible values for the what we call that. Okay, so let's move on to this. So for the first part, let's write the what is given here. So total land we have 5 ana. So in this total land is space covered by a house, which is area of house. Yes, space covered by a house is 4 power 2 minus x ana, and space covered by kitchen garden. Which is 4 power x minus 1. Okay. So after this, now space covered by house is this much, and the remaining space covered by the kitchen garden is this much. So when you add these two land, when you add these two areas, these two space, that space will be equivalent to the total land. So we know, you have to know, you just use the common sense here. We know space COVE covered by house plus space covered by kitchen garden. Kitchen garden must be equals to total land, which is space covered by house, we have 4 power 2 minus x, and space covered by kitchen garden 4 power x minus 1 is equals to total land, we have 5 ana. Okay, now this one is the required answer for this I number. Make the exponential equation that we have made here. Okay, so from this we made the exponential equation. Now for this second part, this double I, solve the equation for x. You just now solve this. 4 power 2 minus x plus 4 power x minus 1 is equals to 5. Break this down. 4 power 2, 4 power minus x plus 4 power x, 4 power minus 1 is equals to 5. Or 4 power square, that will be 16. 4 power minus x, 1 by 4. 1 by 4 power x. Okay, this will be 4 power x, and this will be 1 by 4. Okay, now replace the variable, this replace this 4 power x by some other variable, let. Okay, let 4 power x be what? A. Then what you can write here is 16 1 by a plus a 1 by 4 is equals to 5. Now you can write here 4 times a, LCM. So 16 times 4, 64, and this will be a square here is equals to 5, or 64 plus a square is equals to 4 5s are 20 times a. Now bring all to the left hand side. So try to bring this into the the standard form. A square minus 28 plus 64. Okay, 16 times 4, 64. 16 plus 4, 20. Or a square minus 16a minus 4a plus 64 equals to 0. Okay, not much space here, so I'm going to rub this. Okay, this part here. Okay, you'll be using that no more. Okay. Okay, now after that, okay, take a common there. A minus 16 minus 4 common. A minus 16 equals to 0. So a minus 16, a minus 4 equals to 0. Either a minus 16 equals to 0, or a equals to 16, or replace back the value of a by 4 power x. 4 power x, 16 in terms of 4, 4 power square, equal powers you'll get the value x equals to 2, or a minus 4 equals to 0, or a equals to 4. Replace back the value of a by 4 power x is equals to 4. Nothing means 1 there. Equate powers, we get x equals to 1. So this is the value for double I. Therefore x equals to 2 and 1. This is the value for double I. Okay, so this is the double I answer. And let's move on to the next. Find the area of kitchen garden. So since the value of x is twice, there are two values for x. The possible area of kitchen will also be 2. First we try by substituting the value of x by 2, and then after substituting the value of x by 1. Let's see what we will get. Okay, so I think I'll be needing this. We'll just rub this. So if you don't have any problem, I'll rub this part. Okay, I'll rub this part and I'll resume from here. Okay. So I'm going to rub it. Okay, for triple I part, area of kitchen garden, when x equals to 2, then area of kitchen garden will be, what is the area of kitchen garden? 4 power x minus 1. Anna? Okay, this 4. So substitute the value of x by 2 minus 1. So this is 4. Anna. Yes? Now similarly, when x equals to 1, area of kitchen garden will be 4 power x minus 1. Now substitute the value of x by 1. 1 minus 1, that will be 0. So 4 power 0, 4 power 0 means that is 1. So possible area of kitchen garden will be KITCHEN, kitchen garden will be either 4 Anna or 1 Anna. Okay, this is for number triple I. Okay, for number IV, find the area of plot occupied by the house. Okay, for this house also you have to just substitute the value of x by 2 in the first case, and in the second case replace the value of x by 1. You will get the two values for the area of plot occupied by the house. So when x equals to 2, then plot occupied by house will be what? So space occupied by house is 4 power 2 minus x. Okay, 4 power 2 minus, replace the value of x by 2, then it will be 4 power 0 Anna. It will be 1 Anna. Okay, when the value of x is 2. But when x equals to 1, then plot occupied by house will be 4 power 2 minus x a yani ana, that is 4 power 2 minus 1 a yani ana, that is 4 power 1 ana a yani ana, that is 4 ana. So the possible values for the space occupied by the house will be possible area of plot occupied by the house, occupied by the house will be either this 1 ana or 4 ana. Yes? Yes. Definitely. Okay. Okay, this board is a little bit small, so I have to adjust here by rubbing the space that I need. Okay. Okay. So I hope you understand this tubal A and B. They are both same. Okay, you try a little bit, it will be easy for you. And on the other hand, you just this type of questions will be has more chances that these types of questions will be asked in the examination. So you just give more emphasis on this type of questions. Okay, so we move on to the next questions. This might be the last questions for today's video. Okay, so let's move on to the table C number. Okay, I think if you have finished this, so I'm going to rub it. If you haven't, just take a screenshot. Okay, now let's move on to the number table C. So this will be the last questions for today's video. Okay, the manufacturing company produced the cottons of having its volume. Okay, that this is the volume of the cartons. Okay, so just write whatever data is given there. Volume of cartons. Okay, so volume of cartons there is 5 power m plus 2 minus 5 power n centimeter cube. So this is the volume for cartons. So inside these cartons, there is kept small pieces of iron, and the volume of each pieces of iron is 5 power m minus 5 power m minus 1 centimeter cube. Now volume of iron pieces, that is 5 power m minus 5 power m minus 1 centimeter cube. So in I number, how many boxes with iron can be kept inside the carton? How many boxes with iron? Keep the iron boxes with iron, having volume to keep the boxes with iron, ease of having volume this. So inside this volume of cartons, so volume of iron containing this much volume will be kept inside this cartons. So in I number, how many boxes with iron can be kept inside a carton? How many boxes with iron can be kept inside carton? Okay, so it will be better if I write here volume of boxes with iron, that is given 5 power m minus 5 power m minus 1 centimeter cube. Okay, so now this I put it in this way, so this will be better. Okay, because in the questions, how many boxes with irons kept inside the cartons? Okay, so volume of cartons in the carton is given here, and volume of boxes with iron is kept inside this carton. So how many boxes with irons can be kept inside this carton? That is what is asked in the number I questions. How many boxes with iron can be kept inside the carton? Now number of box here, number of boxes with iron that that can be kept inside the cartoon is given by a big volume divided by small volume. So this cartoon has to have the biggest volume, and this which is to be kept inside the cartoon, that will be the least volume. Okay, so volume of cartoons will be the big, so always volume of cartons, this wall because this is the biggest volume, this will be the biggest in comparison to these boxes, volume of boxes with iron. So volume of carton will be written on the numerator and divided by volume of boxes with carton, volume of boxes with iron. Okay, now here volume of carton we have 5 power m plus 2 minus 5 power m whole divided by 5 power m minus 5 power m minus 1. Try to disintegrate this. 5 power m, 5 power square minus 5 power m divided by 5 power m minus 5 power m, 5 power minus 1. Yes? Okay, try to get this 5m common here. 5m is take common, then there will be 5 square minus 1 whole divided by, here will be 5 power m inside the bracket 1 minus 5 power minus 1. So on further simplification, I'm going to write here is multi-space. Okay, this 5 power m and this 5 power m will get cancelled, and the 5 square minus 1, that is 25 minus 1, and in the denominator 1 minus 1 by 5. So 25 minus 1, that will be 24, and here 5 ones are 5, 5 minus 1, 4 by 5. Okay, so on further reciprocal, 24 by 4 into 5, 5 will be in the numerator. So 4 how many times 24? 4 times 6, 4 6 are 24, 6 5 are 30. So such boxes with irons, 30 boxes with irons can be kept inside this cartons. Okay, very easy. So this is how you get this. Always remember. So while finding out the how many number of boxes, how many number of things that will be kept inside the some of the vessels, so you have to uh, divide divide the volume of vessels which the things has to be kept inside. The volume of big vessels divided by the volume of things which are to be kept inside that vessels. So with that scenario, you will just get the answer how many pieces will be embedded inside that vessels. So here the volume of cartons is like this. The volume of cartons is here given, and volume of boxes with iron which is to be kept inside these cartons. Okay, so this volume of cartons which is comparatively bigger than this boxes with iron, because the things which has to be kept inside some things, this will be this must be or has to be a lot more larger than this one, the things which is to be kept. Okay, so in that case you just you just you just try to keep that in the numerator, the biggest volume, the biggest volume. Try to keep that in numerator divided by the things which has to be kept inside that vessels, or the volume is to be in the denominator, and you simplify this, you will get the number of the, the number of items that can be embedded inside that box, vessels, or whatever. Okay, so I think this one you have already read in the unitary methods in the previous smaller class also. So in those classes, there will be, instead of this exponential equation, there has to be there have been numbers. Okay, the numbers, numerical values. Now here, instead of numerical values, we have given this exponentials equations. The theme is same, the concept is same. Okay, the bigger volume divided by smaller volume, and smaller volume should be the volume of objects that has to be embedded in that bigger volume. Okay, that has to be kept inside in that bigger volume vessels. Okay, so number I finished. How many number of boxes with iron? 30. The number of boxes with iron that can be kept inside that carton is 30. Okay, after that, if the volume of each carton is 15,000 centimeter cube, find the volume of m. Find the value of m. So here you have to find the value of m. If the volume of each carton is 15,000 centimeter cube, okay. If the volume of each carton, this is the volume of each carton. Okay, if the volume of each carton, the numerical value is given here. Okay, this is the exponential equation. This is the exponential expression, and the volume of numerical value, the volume of numerical value of carton is given here, 15,000 centimeter square. Then you have to find the what will be the value of m here. So we have to find the value of m here. So I'm going to rub this. Okay. 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 Okay, now let's move on to the number II questions. So in II, if the volume of each carton is 15,000 centimeter cube, okay. So volume of cartons we have already given. We have volume of cartons is already 5 meter, 5 power m plus 2 minus 5 power m centimeter cube. We have already given this. Now if the volume of cartons, the numerical volume of cartons is given, so what will be the value of m here? So volume of cartons is given here. We have 15,000 centimeter cube. Now no need to write this centimeter for now. You just simplify 5 meter plus 2 minus 5 power m. This is not meter, okay, this is m. So we have to find the value of m here. So try to disintegrate this and break this down. 5 power m, 5 squared minus 5 power m. Okay, now here you can let 5 power m be a. Now you can write 15,000 equals to a. 5 square means 25 minus this will be a. Yes, a. This will be a. Okay. Or 15,000 equals to 25a minus a, or 15,000 equals to 25 minus 25a minus a, that will be 24a, or a is equals to 15,000 divided by 24. What will be the value of that? Okay. $15,000 divided by 24. That will be 625. This will be 625. Okay, replace back the value of a by 5 power m. Okay, 5 power m, and this will be try to convert this 625 in terms of 5 power 4. So we have the same base here, equate powers, you will get m equals to, yes. Okay, this is the last video for our this was the last questions for our today's video. So if you like my video, don't forget to like, subscribe, and hit like button to my channel. And if you find this video more convenient and more useful, you can share it to your friends. Okay, you can share it to your friends. It might be more useful for them to come in handy, and this type of questions will be, has more chance, so you must focus on this type of questions. Okay, on the other hand, uh, we have just finished the the very first exercise of this exponential equations, exercise 10.1. Yes, congratulations, we have just finished that chapter. Not the chapter, the first 10.1 exercise. Now we'll be starting the another portions of this exponentials equations. Okay. Okay, until then, goodbye, take care, and see you. Okay.